This video is on Vesper theory and shapes of molecules. Vesper theory is an acronym. Vesper is an acronym for valence, shell, electron, pair, repulsion. Okay, so you get your the first letter of each word put together as Vesper. So this is, write this in blue. This is that valence electrons, remember, because they're all negative, repel each other, so they spread out. As far apart as possible. So this means, like, if, for example, if you have some element X, let's say, and it makes two bonds, the bonds are not going to be here and here because there's this repulsion between them. They're pushing the other one away because they're all negative. So really what will happen is you would have something where they would be as far apart as possible, which would look like this. So when they repel each other, right, from here to here, that's an equal repulsion as it is from here. This is as far apart away as possible. So that leads us into our shapes of molecules. So there are 5 different shapes that you need to know. So we're going to write down the shape. We're going to do a drawing kind of with just generic like A's and X's for letters. We'll talk about what goes in the center, like what types of atoms would make this shape, and then what that bond angle is. So first we will put, the first shape is linear. And that word linear, right, means line. So what we're going to do is we're going to have something like some element X, like I just had up above, bonded to one or two other things, but they're going to be in a straight line. So elements that bond like this are going to be elements that have 2 lone electrons. Okay, so, or 1 lone electron, because you could have one that bonds just like, you could have just this too. Okay, that would also be linear. Okay, so these will be things like group 1, 2, or 17. So something like magnesium would bond like this. Something like chlorine would bond once, right? Because it's got that 1 lone electron. All right, things like that. So the bond angle then, if you look at the distance, right, from here to here, that would be 180 degrees, right? Half of a circle. Okay, however, if you have the 1 lone electron, so like this X A situation. So if you have X, XA, oh, come on, pen. This would have no bond angle because you don't have anything to go around, right? There's nothing to hit, nothing else to hit. All right, so the next shape we have is trigonal planar. So trigonal planar, right? Trigonal means 3. Planar means it's going to be flat. So like if you turn it sideways, it's all going to be in the same plane. It's going to look flat. So this would be something like if I have some element X and everything is going to be spaced out in thirds around it. You kind of see that triangle shape there. Okay. Sometimes you'll see this drawn like this though, more 2 dimensions, but this is the same shape when you see it drawn like this. Okay, so things that bond like this are going to be things that have 3 lone electrons. Okay, so this is going to be things that are in like group 13, like boron or aluminum. All right, so your bond angle here, if you have this, right, and if they're all equally spaced, you're going to get this distance from here to here is going to be 120 degrees, right? A third of a circle. So 360 divided by 3. All right, our next shape is tetrahedral. All right, and tetra means, right, because tri means 3. Tetra means 4, okay? But 4 in 3 dimensions is not the same as 4 in 2 dimensions. 4 in 2 dimensions would be more square-like. This is going to be more like if I have something here, 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 and then kind of back like this. And I'll show you this in person in class. You can see what it looks like in 3D. But the way we draw it on paper looks like this, right? And force all the way around. All right, so things that bond like this have 4 lone electrons. And this would be things that are in group 14, like carbon or silicon. And so your bond angles here, it's not as simple as just a fourth of a circle, because now we're talking spherical, because this one is not flat. So this one isn't as kind of simple or easy to figure out. This one is a number you're going to have to work on memorizing. It's 109.5 degrees. All right, our next shape is trigonal. So again, we've got 3, but not planar. This is pyramidal. Okay, so we're going to have that kind of, here's our central thing, these 3 down, and you have a lone pair up here. All right, so this one drawn is going to be when we have something like this that bonds 3 times, just like the planar one does. However, it has a lone pair right here, which repels those bonds away, those other ones. So this is not going to be flat, and it's going to be different elements from the trigonal planar ones. So this is going to be ones that have 3 lone pairs, 3 lone electrons. Okay, plus 1 lone pair. Okay, so this is going to be like group 15. So this would be something like nitrogen, which has a lone pair right there and 3 single electrons. Or something like phosphorus, which has the same. Okay, so then again, this is a little more complex in terms of its bond angle. So a number to memorize with this shape is 107 degrees. All right, the last shape for you to know is bent. Okay, and if you've noticed, we've kind of gone through like a pattern, like we've got group 1 and 2, and then we skip across to 13, 14, 15, 17 was up with linear, so this last one would be group 16. And these are things that bond twice, but aren't linear. So something like this, bonds of these 2. And if I show you this, you're going to be like, wait a minute, you just told me Vesper theory tells me this doesn't happen. You're right, it doesn't, unless you have these other electrons repelling them away, those bonds away. So this will happen with elements that have 2 lone electrons, those are the ones that bond there, plus 2 lone pairs. All right, so this is going to be group 16. So this will be something like oxygen. All right, you see the 2 single ones there, and then the 2 pairs. Or something like sulfur would work the same way. There's 2 pairs, there's 2 single electrons. So another kind of weird one to memorize is 104.5. All right, so these are the shapes, and these are the shapes that work because of Vesper theory. And in class, we will go over more of how to draw these now that we've done the drawing and naming the shapes. And we'll build with the kits so you can see these in 3 dimensions.